All right. If you remember, this is the slide that we ended with last Thursday. And we were going over some kind of important components of statistics, and that is the p-value, the effect size. And I stopped with the explanation of the normal distribution because we got to slow it down a little bit right here to really understand when we use what we call parametric statistics, which is the preferred method and the most stable method of analyzing data, or there is another form called non-parametric methods, which is which are used when data don't conform to what we call the normal distribution, and it's more of a categorical type of variable. So let's start though with defining variables. Okay, so whenever we talk in statistics, we talk basically about two types of variables. Now, a variable is something that can be measured, and it can vary from sample to sample, or from when we're dealing with human statistics, from individual to individual. It can vary from individual to individual. Okay, the two types of variables that we look at are one is called categorical variables, and the other is called continuous variables. Categorical variables are variables where well, basically, I can't think all of a sudden. Categorical variables are things that are when we put things into topics, into different areas based on a quality that object may have. Probably the most kind of common one that is often measured is gender, male, female, or other, right? So if you have male qualities, you fit in the male category. If you have female qualities, you fit in the female category. And then if you don't fit in one of those two categories, you're somewhere in the other category, in other place. So other types of categorical variables include types of trees and plants. All those are categories, right? Continuous variables are variables that can change over time, place, situations, and it has a 0 point and then some usually end point. And individuals can be anywhere, somewhere. The measure can be anywhere on this continuum. All right. Examples, some very solid examples of continuous variables are age. You have a 0 point and you will have an end point, and right now you're somewhere in between those 2 points. Okay. Growth, height, tree growth, people height. Those are all kind of really good examples of continuous variables. You know, within the field of psychology, we measure things like loneliness and happiness on a continuous measure called a Likert scale, which we will get to here in a little bit. So categorical variables usually have to use the non-parametric method. And usually when we're comparing two categorical variables, like answering yes or no on a questionnaire, what we're most wanting to know is we just want to view or display the data so that it makes sense. So let's say we have a yes, no on are you happy today? Okay, that we've turned that into a categorical measure. Either you are or you're not, yes, no. And what we'll most likely do is come up with a bar graph displaying how many said yes, how many said no. And then there is a non-parametric method that we could inferentially look at that data and see if it represents the broader population. Okay. Continuous variables, on the other hand, what we want to see is for them to go into what's called the normal distribution, or to fall into what's called a normal distribution. This is also called the bell curve. It is a way of looking at a continuous variable and the sample that you have. Okay, so how does this work? Let's say we are measuring something like well, let's just go, let's you know what, let's do IQ scores, because they have some features about them that are unique. Okay, so IQ scores have a range. You can score anywhere from 0 clear up to like 160, I believe, sometimes even higher. So we have a 0 point here, and let's go with let's do the upper limit of 145 tends to be the high end. Okay, all right, so this is the IQ score, and what we look for is that we know not everybody's going to score a 0. In fact, we hope no one does, because you're probably dead if you do. And 145. And what we want to see is, so these are the scores on an IQ test. Now, what's going on this axis is this is the number of individual scores of people. Okay, so if you think about this as a kind of a distribution of scores of individuals, so everybody is somewhere under this bell curve that we've sampled. Okay, so this represents the number of people who scored right here in the middle. Okay, so everybody in here scored here, and then we have less people scoring up here and less people scoring down here. Okay, this distribution, when we start to analyze data, is the distribution we want in order to compare two different things, or 2 or more different things. Okay, so let's look at the unique qualities of the normal distribution. Okay, well, we know that in the normal distribution, the mean is right in the middle. The mean is the average of all the scores together, and of course we calculate the mean by adding up all the scores and dividing it by the number of samples, the n. Whoops. Okay, n represents sample size. Okay, now we'll go back to the IQ example, because the unique features of an IQ is that the mean score, the standardized, what we call the standardized score for a IQ test, is 100, meaning that the average person, meaning the person where there's people who score 50% less than that individual or 50% more, has an IQ of 100. That's our average IQ score. Okay. When we look beyond the distribution and we start looking at what's called the standard deviation, and remember what I said about standard deviations last week, they're basically the average difference between individual scores. They give us what's called the spread between scores. Okay. When one of the unique qualities of the normal distribution is that the standard deviation and the mean can tell us a percentage of individuals that score within a given range. Okay, so again, we go to our IQ example. The average is 100. and the standard deviation is 15, okay? So in our example, the distance between here and here is 15, okay? And then if we go out another standard deviation, there's another 15. So right here, we are at 115. And now we're at 130. Now, what does this tell us? Well, let's go to the next slide. All right, remember we have 15, 15, and then another 15 here. And what it can tell us is we know that 34.1% of people will fall between 100 and 115. Okay. We know that people who score between 115 and 130 represent 13.6% of the population. And then between 130 and 145 represents 2.1% of the population. And then anything above 145 is 0.1% of the population, okay? If we take it out broader, because we can go this other direction, right? So we go 100, no, that's wrong. 85, 70, and then trying to do math in my head, it's 5. 45, okay, 45, all right. And we go this direction. Now we can tell people who score between 85 and 115 represent 68.26 of our population, or of this sample, okay? And we can take it out further and we can see that 95% of people basically score between 70 and 130, okay? And so this is kind of what the normal distribution can do for us. And it can tell us a lot of things about the sample and about where people score. But when we get into analyzing data, this is where the distribution becomes very important, because I'm going to go back to this one here, and instead of IQ score, let's do something else. All right. All right. What we're going to do is we're going to measure how much someone, how masculine or feminine someone is on a scale of some type. So this one is going to have, let's put femininity on this side. So people who score have more feminine qualities are on this side of the distribution, and masculine qualities, so feminine to masculinity, okay? And we know that everybody kind of scores somewhere in between. And let's compare, for the sake of this one, let's compare the binary men and women, okay? And let's say this distribution we have right here, this one, let's say this distribution represents women, okay? And of course, if we measure it long enough, we're going to get a bell curve, okay? Well, what do we know about the stereotype about men and women? Well, we know that women will have more feminine qualities and men will have more masculine qualities. And so let's say we want to compare this and test this and to see if there is indeed a difference between men and women on a continuum of feminine and masculine. And what we'll find is that, you know, probably men will score on average more masculine than feminine. And so here we can go, okay, we know that women and men, there's a difference in their masculinity, okay? And using the mean, we can say men are on average more masculine than women, okay? But this is why we have to use statistics, because if we try to draw out this distribution, sorry for my artwork. All right. Let me try that again. All right. All right. So as we can see, if we draw out the colors, what we have a totally different story that starts to evolve. And I apologize about my coloring, because what we find when we actually put the distributions together, that we can say, yes, there are a few men, there are men who are more masculine than women. And this should have been drawn a little bit better. Let me. All right, this makes more sense. Okay, there are men who are more masculine, and there are women who are more feminine. But the question we have is, what about all of these people? Here, let me do this in a different color. What about all of these people that scored exactly the same? All right, so could I really say there's a large difference, or there's a big difference between men and women when there's such an overlap of the distribution? And this is why we will get into statistical testing, because that's what these statistical tests do, is they take in the means, they take in the average consideration, but what they're really interested in, what we really are looking at, is the variability. How much do two populations really vary from each other? Not just on average, but overall. And that's really what the statistical tests that we will be doing will tell us over the next couple weeks when we get into inferential statistics. And so this is the normal distribution. I'm going to stop here and just ask, because this is an important concept, does anybody have any questions at this moment about the normal distribution, how it works, what it's about? So any questions?
No.
Right. Thank you, Diana.
No, nothing yet.
All right.
Not right now.
Not currently. I've been taking notes.
Good. Okay. All right. All right. So let's bring. Okay.
I do have one question. If we have any
Question, can we email you like
Yes, definitely.
when it comes up? Okay, all right, perfect. Thank you.
Okay. So that's a normal distribution. That's what we tried to do. That's one of the first tests that we do before we can even test data, is we have to determine whether the distribution is approaching what we call normal. Distributions can be skewed to the left or to the right. But what we were looking for is that if it's not normally distributed at the time of analysis, the test that you'll run will determine whether or not the distribution will become normal. And if it's not, then you basically cannot run the test that you normally run for that, and you'd have to use, again, some non-parametrics, and I don't mean to make it sound like they're not important, but they're just not as robust as the parametric method. Okay. Now, where do we get the data from? Comes from the idea of sampling. All right. And remember our conversation about probability that we had last week. Okay. Because we basically have 4 types of sampling. We have random samples, and this is when anybody within a population has equal chances of being measured. Okay. So let's say we have 100 individuals, and we're only going to sample 10 of those individuals. Okay, well, each person would have then a 1 in 10 chance of being sampled. Everybody has an equal chance of being sampled. Okay. When it comes to research and those, random sampling is, while it is the gold standard, it's not always possible, especially when you're dealing with human subjects. Where you actually have to get permission. The sample, the individuals have to agree to be measured, in essence. So what, at least in the science area, what we are usually stuck with is something called convenient sampling, and that's basically, everyone doesn't have an equal chance of participating because it's a choice you basically don't have the ability to do random sampling with a lot of research. More so when you get into the business realm, marketing, those types of things, we usually use what's called either a stratified random sample or a purposeful sampling. Stratified random sampling is when we random sample of a certain individual within a population. So within my area of psychology, let's say I was going to study autism. So, I get access to individuals who had been diagnosed with it, and I try to do the same thing as a pure random sample and have individuals participate in my research, and everybody within that certain population would have then an equal chance of being chosen. Okay. Purposeful sampling is sampling of a very, very specific population and situation. So the example here would be kind of like a program evaluation. So it's a very specific thing. You will choose the individuals who will participate in the research and the like. Okay, and this is a purposeful sampling is really used in marketing when a marketing company wants to look at a certain product and a certain brand, and then see what its trend will be in selling towards certain populations. So the reason why sampling is important is, as I stated, random sampling is a gold star, because what it allows us to do is, if in a sample everyone has an equal chance of being selected, then that means that the results of that research can be inferred on the population which the sample was taken from, meaning that because everybody has an equal chance, that statistically, the sample represents the population because everyone had an equal chance. When we get into convenience sampling and stuff, that argument becomes weaker and weaker because the probabilities aren't there. Basically, our samples were there more by luck than they were by chance or probability. Okay, so this is where our measurement's going to come from, is the type of sampling we do, and we do need to note the limitations of any type of sampling that we do as well. Okay. All right. We talked about power. I'm trying. Yes, Diana.
So would you say that, so I was an assistant manager for Circle K for a while. So would you say I was doing purposeful sampling? Because my manager and I would have meetings on where to put stuff in the store, what would sell faster than the rest. And that's how we set up our stores. Is that what I was doing?
Yeah, so yours would be considered purposeful sampling because you're dealing with a certain thing and you're looking at placement and how it then would go through that product. Yeah, so that would be a good example of purposeful sampling. Real good, actually. So, okay. I wanted to. Okay. Trying to decide. What to do with this. Okay. Okay, I think I want to hit this one tomorrow. Okay. Yeah. Okay. Okay, this is what I think I want everyone to do for the remainder of this class. Now that we've talked about the types of variables and whatnot, is what I'd like you to do is I would like you to develop a question that could be answered statistically, meaning that it's a question that can be measured in some way. And what I'd like you to do is determine whether or not you feel like it would be a categorical, the measurement, whether the measurement would be categorical or if it would be continuous. Okay. And then what I would like you to do is come back tomorrow with tomorrow's class with your variable, your question. So here I better, I'll put it in the chat. So this is what I'd like you to do. Okay, so some question. That can be answered with measurement. Okay. Okay, and then the second thing I want you to do is determine whether it would be a categorical or continuous variable. When you measure it, okay? All right, so that's what I'd like you to do, and then come back tomorrow and then let's discuss your variables. And then I think what we'll do with that is make that kind of your semester project. So I'll get the data for you and you'll use that and you'll analyze it as we go. So does that make sense what I want everyone to do
Yes.
Okay. All right. Thanks, everyone. Okay, so let's go ahead and close our Zoom class up for today and go ahead and use the rest of the time to go get the question and then determine if it's continuous or categorical. And then we will come back tomorrow and talk about them. All right.
Sounds good. Thank you.
All right. Take care, everyone.